Hi, welcome to the third video in a series about Commodore power supplies. A great deal of this video was shot more than a month ago, and I'm just now getting around to editing and uploading it. I'm still getting used to the hang of working on something while filming, so please excuse the numerous shots of the back of my head and my hands. Thanks, and let's get on with it.
Okay, here is one of the aftermarket power supplies that were available for the Commodore 64. It is a Phoenix CPS-10. There is no markings on it to indicate what its ratings actually are. It does, out of frame. It does have an on-off switch. Unfortunately, it's riveted together in several places. On the back panel, there is a external fuse, 120 volts in, DC power out to the Commodore, and a couple switched outlets. So I guess you could switch on your monitor at the same. Got our cords here. Notice this one also has all 8 pins, and the connector is kind of worse for wear. It's broken, and the cable seems rather skinny for its purposes. Here's the other side and the bottom. Phoenix Electronics, California. And of course we're missing a couple feet. Okay. Got our trusty drill here, and an 1/8 inch or 3mm bit, and we will try drilling this guy out. Okay, looking at the rest of our rivets out. Oh, that is dusty. Here we go. Looks like a pretty substantial transformer. Don't see any markings on it. Let's have a close. Okay, so here's the inside. That is a regulating transistor. And here is a voltage regulator board. LM723CN. Potentiometers. This is kind of a roll your own voltage regulator. A couple little weeny diodes. Okay. Here is our transformer. So we've got power comes in over maybe a 24 gauge wire. That's the AC, and that's not real impressive. Through this bitty switch down onto the board. Okay, if we look at our outlets here, they are going over to this guy, so I bet this is a triac our SCR that is turning on the AC outlets. Okay, so these two teeny tiny wires here are a 9-volt AC, and man, if that's 24 gauge, I would be surprised. And so this is going to be our center tap. Oops. Here to where you can see. This is going to be our center tap and our two legs. A couple little weeny rectifying diodes. I'm not sure what this is. Yeah. Mr. Gus decided to give his expert opinion. That capacitor right there. Well, both of those are scratched or cracked the same way. Oh, if we look on that one back there, it's a stripe. Some other things written on there. AC into, oh, okay, this is the AC into the board, which is going through some filtering through the switch. And this is the AC in into the transformer. Okay. I have it hooked up here measuring the output voltage with no load. You can ignore the fact that that says minus 5 volts. That's just the way I have the leads hooked up. So I'll see here how that is. So I'm clipped on here at this resistor, which is connected to this red wire here, which is the 5 volts. And you notice how small the gauge is on that wire. That's about 24 gauge. There is a good 18 inches of wire coiled up there, and the red lead is actually on the ground side over here, which is why it shows negative instead of positive voltage. But anyhow, so we've got our 5 volts there. Now what I'm going to do is move this clip over to the actual 5 volts coming in. So what we're doing now is measuring the 5 volt voltage drop from this, or the 5 volt voltage drop. We're measuring the voltage drop across this 24 gauge lead, and this is just one of the wires. Voltmeter, now you can see that we have virtually no voltage drop because there's no load. And if we turn on half an amp load, we have about 30 millivolts, and again you can ignore the negative sign there. And we turn on another amp load, so we have an amp and a half, and see we have about 95 millivolts across one of the wires. So altogether that is about 190 millivolts that we're dropping across the two wires because of the small wire they used. And we can confirm that by so now we're measuring the 5 volts at the load. Let me get up here so that's straight. You can see it's 5.06 volts. Half an amp load. It's dropped down about 60 millivolts with an amp and a half. It's 4.86, so it has dropped down 0.2 of a volt under load, which is more than what we would like to see. Now the thing is, this voltage regulator chip here, see if I can get a little closer, this is the voltage regulator chip. It's measuring the 5 volts right at this point. So it does not see that voltage drop. Okay, this does have a pot right here which should adjust the 5-volt output. So if we adjust this, okay, if we adjust this so we get right at 5 volts with it under load, when it's not under load, or it'd have closer to 5.2 volts, which would be okay. It's better to have that under load, so it's not the case. So I'll try to get you around here so maybe you can kind of see what I'm doing. And maybe kind of, how about that? That's a little better. Okay. What we've got to do here is remove the wires to the side. Switch out of her way. And I think for the most part we can get the board out of there now. So we've got the board loose. Get him up like this. Okay, so here's a close-up of the back of the board. It says SDZ Electronics 700-113. So we'll have to look that up and see what it is. So this has all the hallmarks. See if you can see that, of being hand soldered. That is what I would suspect. Okay, what we're going to do here while I've got this apart is replace this 24 gauge wire with some 20 gauge wire. So I slid back the insulation that was on the 9 volt output here.
I'll just flip those guys off. Take the marker here on the board. You mark which one? I marked this as negative right here, so I wouldn't. Yes. Carefully. That one. Sucker's not sucking. No. It came unplugged. That sounds more better. notice this neutral wire is sticking over here, dangerously close to the ground.
Okay, so we've got our 4 conductors here free. Tease out that. Now we've got this guy out, which is the strain relief. Okay. So hopefully the strain relief will. Yeah, that'll work. Okay. So this is just a piece of 4 conductor 20 gauge scrap wire I've been laying around. What I'm going to do is slide this guy back out of the way and mark out how long I want to strip these wires based on the other one. About to there. And this guy I'll just wrap up. Wrap this one up too. Scrap. Now, right here's my mark. This tool is actually a coax stripper that I removed the center cutter blade out of. We'll just use that, and it's set for this size cable because I use it a lot. I'll give it one more wrap around there. So we make it just deep enough that when we flex it, you can cut through the outer covering and not the wires. Get this back down here where we can use it. I was a bit wrong on my guesstimation of the length of that original cable. It was almost 4 feet. This cable's a little over 4 feet, so I'll cut a little off the end here to get past this stuff, and then we'll be fine. So we'll go through Mr. Strain Relief like so. Okay, so the original strain relief was too small in diameter for the larger cable, and I happen to have this gland nut around here, which is a suitable size, and it fits in the original hole. So we will. Okay, now we've got the gland nut tight in there. I'll run the cable in so we have, a quarter of an inch, 6 or 7 millimeters of the sheathing through there. We'll get a close-up of that later. Tighten the back part of the gland nut. Now, we want the green and white to go up here, like so. So we'll cut those guys off about right there. I'm not cutting these as short as the original. I don't like having wires that tight inside of things. the red and black are the DC, and the polarity matters. So we got to get those in the right hole. Okay, so we've got those two guys soldered on there. Get a little bit of solder out of there. Trim these to length. Inspect their work. Okay. What I'm going to do is hold on to these on the bottom. Does flow out, so these traces are rather thick, and I've got to make sure that our solder flows out nice. Okay. Let's get you. Okay, so in your view, these two pads on your left here and here are what I just resoldered, and you can see those are really thick traces, so I went back and I heated them up again and let the solder reflow out, so we have some nice shiny joints. This is good old leaded solder, so that's what it should look like. And after I put the camera back on the tripod, I'll have a peek at this board again, maybe clean the flux off here with some. Okay, just a quick shot. I wanted to show you how much better the back of the board looked once all that nasty old flux was cleaned off of there. Notice here, there's this empty spot with these two holes. I suspect those holes, which would have been the same as here and here, were for the press-in a 1/4 inch spade lug, which they intended the AC out to be hooked to. But you notice we only have hot neutral here. They didn't bother to hook the ground up. They just snipped the ground wires off from the outlets here, which is stupid. Okay, we've got the open circuit voltage here on the Phoenix CPS-10 after I've reworked it a bit. What I've done is replaced the 24 gauge power lead with a 20 gauge. Same length, about 4 feet, a little over a meter. And all this nasty AC wiring that was just shooting directly across the top here with the green wire for the hot. And the little green wire that was here, I've replaced those with little larger black wires to keep the indication that it's hot. And put some heat shrink tape here on all the exposed mains voltage locations. Now, after testing this with the load, here we go, we'll just jump up to the full 1.5 amp load. Go from 5.2 volts open circuit voltage to 5 volts loaded voltage. So the voltage drop wasn't very much in the cables. Okay, so now we got her all buttoned up. Cleaned it up with a Mr. Clean Magic eraser. Replaced the rivets with some self-tapping screws. I only had 5 though. I'll have to find another one like that. We replaced the power cord to the C64 and the connector, and redid some of the wiring on the inside. So we've got a nice little power supply now.
I hope you've enjoyed this look inside the Phoenix CPS-10 power supply for the Commodore 64. If you have any questions or comments, please leave them below. And if you like what you see, subscribe. I think next we might do something other than power supplies, and then maybe come back and look at the Commodore 128 power supply. Thanks for watching, and I hope to see you again.